Hey guys, so last section of the probability assignment, and this is all about compound events. So there's two vocab words that we first need to clarify before we start calculating those vocab words. So we have mutually exclusive events and overlapping events. When we talk about mutually exclusive events, this means there's a situation where the result can be one or the other, but never both. So for example, if you were rolling a dice and you needed to roll a 1 or a 6 in order to win the game, um, that would be a mutually exclusive event because you can either roll a 1 or a 6. There's not really a case where you would be rolling both a 1 and a 6 with just one dice. All right, overlapping events. This is a situation where it can be one or the other, or possibly both. So for example, if you were rolling a dice and you needed to roll either an even number or a number less than 4, we would have some overlapping situations where it could be an even number, it could be a number less than 4, or it could be an even number less than 4. So that would be where it's overlapping. All right, so what we did in class is we just kind of used those definitions to identify 12A, B, and C, and D either as mutually exclusive or overlapping. Okay, so the probability you roll a 1 or a 6. We already kind of used that one as an example. That one's mutually exclusive. You could either roll a 1 or 6, not really both. Okay, so I'm just going to put an M by A. If you wanted to mark them the same, that's absolutely fine. What is the probability that you roll an even number or a number less than 4? We use this one in the example too. That one's overlapping, right? Because you can get an even number, you can get a number less than 4, or you can get an even number that's also less than 4. What is the probability that you roll a 2 or an odd number? All right, this one tricked a few people in class. This one's mutually exclusive because you can roll a 2 and you can roll an odd number, but 2 is an even number, so it's either one or the other, right? So that one's mutually exclusive. What is the probability that you roll an odd number or a number less than 5? So this one we can roll an odd number, we can roll a number less than 5, or we can roll an odd number that is also less than 5, like 1 or 3. So this one is overlapping. All right, so we'll go ahead and do 12A in blue and 12B in red. So that way you guys get some free answers and you know how to do the rest by yourselves. So what's the probability that you roll a 1 or a 6? Remember, this was a mutually exclusive. It can be one or the other. It can't be both. So what we're going to do is we're going to find the probability of rolling a 1, add that to the probability of rolling a 6. So we have two fractions that we're adding together. And the nice thing is they both have the same denominator, right? The total number of possibilities when rolling a dice is 6. All right, so let's go ahead and make this first one the probability of rolling a 1 on a dice. All right, the total number of possibilities that meet our constraint is just 1, right? I can roll a 1 and that's pretty much it. All right, we'll make this second fraction the probability of rolling a 6 on a 6-sided dice. So the number of possibilities that meet my constraint rolling a 6 is also just 1. I can roll a 6 and that's pretty much it, right? All right, now I just need to add these two fractions together, and when I do, I get 2 6, which is 1/3, which is 0.33333 repeating. And if we were to make that into a percent, it'd be 33.3%. So your answer for 1 is 33.3%. All right, we'll do 12B in red. What's the probability that you roll an even number or a number less than 4? So remember, this one was overlapping because we could either roll an even number, a number less than 4, or a number less than 4 that is an even number. So what I like to do with these overlapping ones, especially when we don't have like a whole lot of options where there's 6 total possibilities, right? I like to make a list, and then if there's any repeats on my list, I don't add them to my list. So for example, I'm going to make a list of all of the even numbers on a dice. 2, 4, 6. All right, now I'm going to go ahead and write down and add to my list any numbers less than 4, but if I have any repeat numbers, I'm not going to write them down. I'm going to skip them on my list. Okay, so numbers less than 4. So we have 3. 2 is already in my list, so I can't put that one down, and 1. And that's pretty much it. Now I'm going to go ahead and write my fraction just like normal. I have 6 total possibilities, right? I need to find out how many possibilities meet my constraint. I'm just going to count up the numbers right up here on my list. 1, 2, 3, 4, 5. So there's 5 total possibilities that would either be an even number or a number less than 4, and that's accounting for any repeats, making sure that I don't count those twice. All right, so now I'm just going to take 5 divided by 6 to get my decimal point, which is 0.833. And if we were to make that into a percent, I have 83.3%. So when it's overlapping, you're going to go ahead and just make a list and make sure that you don't write down any repeat answers on your list. Make that into your fraction to make into a percent. If you are doing mutually exclusive events where it can be one or the other but not both, you're just going to have 2 different fractions, add up the possibility of getting the result that meets your constraint, add them together to get your percent. If you guys have any questions, feel free to ask. See you later.